Now, one of the most obvious places that we want to control how heat travels is in the home. So if I just sketch my house for a moment, you'll be aware that electricity and gas bills are getting higher and higher, and so people are spending more and more money on heat energy to keep their house warm. But of course we're wasting a lot of that heat energy because our house is warm compared to the surroundings, so the heat energy wants to leave. And that heat energy can leave from a variety of places. So quite a lot will leave through the roof. Now, how do you stop heat energy from leaving through the roof? Well, you could have loft insulation. Well, how am I going to insulate my loft? Well, one way I could use is using something called fiberglass, which is exactly what it sounds. It's tiny little fibers of glass, and I can make fiberglass into a matting. I could even have a layer of foil on the bottom. And how would this work? Well, this silver foil would reflect infrared radiation back down into the house, and this fiberglass has trapped pockets of air. Now, air it's not a very good insulator when it can move, because then it can form convection currents. But when it's trapped, it can't form convection currents. Convection can't occur, but it is still a gas. And conduction only happens in solids. So no heat can be conducted through the pockets of trapped air. So this fiberglass is a great way of stopping conduction of heat. And the silver foil reflects infrared, so loft insulation, brilliant. I can also form cavity wall insulation. So how do I do that? Well, cavity just means hole. And so all I do there is I have a foam between two different walls. And that foam, as you've guessed already, has trapped air. And trapped air is brilliant because it stops conduction, because it can't move for convection, but it's also a gas, so conduction can't happen through it. Brilliant. This is really straightforward, isn't it? Windows. How can I stop heat loss out of windows? Well, I can have double glazing or triple glazing if I really want to. How does that work? Well, I have a layer of glass. I have another layer of glass, and in the middle, what do I have? Well, I could either have a vacuum, so something where nothing's there, or I could have a gas, such as air, although you can pay to have some other gases mixed in with that. And how does that work? Well, if it's a vacuum, there are no particles at all, and both conduction and convection need particles. So neither of those could happen. If you don't have a vacuum, but you do have a gas in there, well, it's a trapped gas, so exactly the same applies as this trapped air. Trapped gas can't do convection because it can't move, but can't do conduction because it isn't a solid. Brilliant. So that's windows sorted. Floors. Our floors will probably lose a lot of heat energy as well. What can we have? Well, we can have carpets and underlay. How do carpets and underlay work? Well, you've guessed it already. They have fibers and they trap air, and trapped air will not allow conduction to happen because it's not a solid. Really, really straightforward. Finally, you might have something in your door. You might have draft excluders by your door. Draft excluders are brilliant. Personally, I like them to be snake-shaped. But draft excluders or seals around your door, they are really good because they can stop air from travelling in or out. Now that's brilliant. That stops convection currents from carrying heat outside of the house. There'll still be convection currents within the room, but that's fine. You want that to spread the heat around the room. What you don't want is any of that hot air to escape or cold air to get in. So draft excluders can be a great way of preventing that. Now, we've mentioned here lots of different forms of insulation, and we need to be able to know how effective is an insulation. Now, there are two real measures. The first is exactly what we just said, effectiveness. How effective is it? How well does it stop heat from travelling? And this is easy because other scientists have done experiments, they've calculated what does a good job, and they've put what we call U values on them. So we can use U values. And all you need to know here, it's totally the wrong way around, but a low U value is a good insulator. Really simple, it's just the wrong way around. So if you know that something has a low U value, that means it doesn't let very much energy through, which means that it's an excellent insulator. But there's another way we can judge how good these things are, and that's cost effectiveness. Now, it might be that the most effective thing to do to keep heat energy in your house actually isn't very cost effective. And as you guessed, cost effectiveness is all to do with how much it costs. Because I could pay £10 for a draft excluder that saved me a little bit of heat energy. Now, it may be that I had something that could save me twice as much heat energy, but it cost 50 times as much. That would not be as cost effective. One of the easy ways to look at cost effectiveness is to think about payback time. And all payback time is, well, we can work it out by dividing the cost of the insulation. So how much does it cost to buy a draft excluder or to put double glazing in, and divide that by the annual saving. So let's have an example. Let's have some double glazing that costs £3,000, and it's going to save me every year, it's going to save me £300 annually. Well, I could take £3,000 cost, divide it by £300 annual saving, and I would end up with a payback time equal to 10 years. Now, this is where you'd have to decide, is that something that's worth investing in? It's going to take me 10 years before I've saved the cost of that double glazing. Now, if the double glazing is only going to last for 5 years, then that's definitely not cost effective. But if it's going to last for 20 years or 30 years, then suddenly I'm starting to make some significant savings in the longer term.